All right, I want to take a look at some more improper integrals here. These are the second type of improper integrals where you've got an asymptote involved, that the function heads to infinity somewhere. And to start with, I want to look at it where the asymptote happens at the right-hand endpoint. So your function, if you're integrating from a to b, then somehow either headed to plus infinity or headed to minus infinity, but there's a vertical asymptote at b, and the function's headed uphill like that. Okay. So the definition that we give is that we're going to look at the integral from a to, let's say, b minus some little bit. Let's say b minus delta, how about b minus h? There we go. Of f of x dx. So subtract a little bit off there, so b minus h would be right here, and integrate that, and then take the limit as h goes to 0 from the right. So you're subtracting positive h's off and you're headed towards 0. Okay? That's what we mean by this thing, that you don't bump right up against the asymptote, you stop short and then take the limit as you go up towards that asymptote. Likewise, if I were doing it on the other end, if I had the asymptote at a, so that the asymptote's here and the graph might look something like that, then I'm going to start at a plus h and then let h go to 0. So on this end, I would be looking at the limit as h goes to 0. H is positive, so h is going to 0 from the right. The limit is a plus h to b of f of x dx. Okay. Example. Actually, I'll do an example of this one. How about the integral from 0 to 1 of 1 over x squared dx? We did 1 over x squared in the last video from 1 to infinity, and as we did this part of it and found a finite area in here, now what I'm looking for is between 0 and 1, where this has an asymptote headed up like that. So I'm looking for this area right there to see what it looks like. Okay. So 0 plus h would just be an h. So I'm looking at the limit as h goes to 0 from the right of the integral from h to 1 of 1 over x squared dx. So that's an x to the minus 2. It integrates to x to the minus 1 over minus 1, evaluated between h and 1, and take the limit as h goes to 0 from the right. So this is minus 1 over 1 minus minus 1 over h. Again, I'm still taking the limit as h goes to 0 from the right. So this looks like, what's this, the limit as h goes to 0. This is just a 1 over h minus 1. The problem is here the 0 is in the denominator. This thing, 1 divided by 0, is getting really big. This is headed to 0. This whole fraction here heads to infinity. So this looks like an infinity minus 1, and so this diverges. So this function, this graph that we looked at up here, where we had finite, this was finite over here, this is infinite right there. Okay. Like the other one, I sometimes don't write the limit. That is, myself, the way I would notate this is just the integral from 0 to 1 of 1 over x squared dx integrates to, again, x to the negative 1 over negative 1, evaluated between 0 and 1. I'm keeping in the back of my mind, I suppose you can't see me when I point at my head to indicate that I'm using the back of my mind. I'm keeping in the back of my mind that I'm not really plugging a 0 in, because that would be, the function's not even defined at 0. But I'm getting something close to 0 and closer. But still, I make it look like I'm plugging the 0 in. So this would be minus 1 over 1 minus minus 1 over 0. And that divided by 0 gives me the indication that, hey, something really is wrong here. that this is going to be a really big number and that this diverges. So it's quite often the case that I don't worry about writing the limit. I just plug it in and take a look at what that form looks like. If it's somewhat of an indeterminate form, then I may have to actually take a limit and be a little more careful. Let's try another one. Let's try the integral from 0 to 1 of 1 over the square root of x. In this case, it's going to turn out that you might even not have noticed that this was an improper integral. If I, before today, if I'd said, hey, do this integral, you'd say, okay, well, this is the integral from 0 to 1 of x to the negative 1/2 power. You're going to increase this to x to the positive 1/2 power, right? You add 1, then divide by that 1/2, so that's multiplying by 2, evaluate between 0 and 1, and you might not even notice that anything went wrong, because nothing does. That is, in this case, yeah, the function still has an asymptote at 0. The graph of the function is doing, is doing something like this, but it actually hugs in really close to the y-axis. And it turns out that this area is finite. It's equal to 2 times the square root of 1, which is 2. That the limit process that we really should be going through, that is integrating from h to 1, and then letting h go to 0, that is, I'm plugging in, instead of a 0 here, I should have an h, but as h goes to 0, the square root of h also goes to 0. And so there's no issue here. When this type of improper integral works, it's quite often that you don't even notice it was improper, but there is an asymptote at that endpoint, and so we have to consider it improper. And in this case, it converged to 2. When the asymptote is in the middle, then you have to break it up into 2 pieces. So for instance, if I did the integral from, let's say, 2 to 3 of, negative 2 to 3 of 1 over x dx, that's got an asymptote at 0. So what I need to do is I need to take that integral from minus 2 to 0 and then add from 0 to 3. If either one of these integrals diverges, then I'm going to say the whole thing diverges. I need both of these to converge in order to add them up and get a finite answer here. Okay. Sometimes it might look like, hey, this is going to plus infinity, this is going to minus infinity, they cancel out. It's like, no, they don't cancel out. If either one of them gives you an infinity here or there, then the whole thing is called off. So let's take a look at this first one. So this would be the integral of 1 over x is the natural log of x, evaluated between minus 2 and 0. And then the same thing here. This would be plus the natural log of x, evaluated between 0 and 3. And perhaps you can already see the issue here. The problem is the natural log function looks like this, and it's got a vertical asymptote at 0. So what do you mean when you say natural log of 0? Actually, I should probably have absolute values in here, shouldn't I? Yes, I should, because the minus 2 was going to give me a problem. This should be minus the natural log of the absolute value of minus 2. And then you got plus this stuff. Natural log of 3 minus the natural log of 0. But what do you mean natural log of 0? Well, what we mean is the natural log of something very close to 0 and getting closer. You're taking a limit, right? You're moving closer and closer to 0, and as the input to the natural log gets closer to 0, the output is getting closer to minus infinity. So this looks like a minus infinity here. So that first integral, this part right here, which is this calculation, is a minus infinity. Now granted, this is also this is a plus infinity, because you've got a minus natural log of 0, so you got the minus minus infinity. So again, you might say, hey, look, that minus infinity, that plus infinity cancel out, and you should just be left with something, maybe 0, I don't know. The problem is it's hard to tell what that something should be, and so we avoid having contradictions by just saying if one side is infinity, and in this case both sides are infinity, one's minus infinity, one's plus infinity, and just say the whole thing diverges. Diverges. It's possible, and it happens sometimes, that on both sides of the asymptote you get finite answers, but if either side diverges, just say the whole thing diverges.